Today I got two products I bought from Amazon that I wanted to show you, and it'll definitely help me with my videos and also my troubleshooting, especially with one of my recent videos that I just put up. First one, as you can see, is a heat-resistant silicone soldering mat. Heat-resistant to 932 degrees Fahrenheit, FDA-approved silicone material, although I have no clue why the FDA, see if I can get there, why the FDA actually needs to approve this when it's a soldering mat. But okay, surface sprayed with anti-static liquid, but that doesn't do anything because there's no way for the ground to go through. Strong toughness and durable. Clean easily. Corrosion resistant and a 10-year lifespan. So, here's the mat itself. It's a nice bright blue. And I got this actually for two reasons. One, I do a lot of soldering on video and off of video. And I've been slowly scoring up my table. And the second reason is, if you can see right here on my table itself, it has a very glossy finish and it always messes with my videos. This has a very matte finish and you can see everything so much better than like when I remove it. See, you got a hot spot up here from the light, and you got a hot spot over here, and you got another hot spot over here. But if I put this down, even when I'm not soldering and just doing regular videos, it's a lot easier to see everything. That's, well, it has a little bit of a glossy on top of it, but that sure beats that. So, yeah, this is a very simple one. There's no magnetics in it type of deal. And it does have a bunch of bins up top here, so you can put components or screws or whatever. And they're actually numbered. Well, at least these ones are numbered. It's probably hard for the camera to pick it up, but it starts with 1, goes all the way to 28, then 29 through 56. And then you got the small, the very large, and the 3 mediums for different components, screws, whatever. So there's the first product, and I like it. Let's actually see how heat resistant it is. So let's see how good it is with soldering iron and solder. So clean it off here. Yeah, it was still liquid. Get off! There we go. Ah! That was hot. Yeah, didn't do anything to it, really. I mean, you go paper, and it's like, yeah, you're going to start etching paper. And nothing here. It's a little warm, but it's not scorching it at all. So, works good for solder. Let's try something else. So, let's say if you're one of those idiots that are playing with solder paste and, oh crap, come on. Oh, what a freaking mess. And then you try just leaving it on over there. And then you're even stupider and you come on over here with a heat gun set at 400 degrees Celsius. Oh man, look at that. Let's turn up the fan even more. And we're just going to like melt all of this. Oh, we can even get the stuff here. It's sitting on top of these tweezers. Woohoo! It's still liquid. It's liquid and partially frozen. Then you get real redneck and you pull out a freaking torch. Woohoo! Fire! Oh, that really caught on fire. Woohoo! Oh. But this didn't burn. Oop, that did get a little too hot. But it's going back down. Oh my god, look at that. Oh, it's still liquid. Look at that. Oh, now I gotta clean this whole freaking mess. Okay, Windex to the rescue. Look at all the bits and pieces. Oh crap. And it's still hot. Oh, This is going to take a few times. Look, oh my god, look at all that crap. It's moving, it's just stuck on there good. Let's see if we can clean it some more. Where's the electronics cleaner? Wow, that evaporated fast. Ooh, that really worked. Let's hit that again. Except for the one little spot right here. And then again, don't forget, I was using a torch that really exceeded the 900 and odd degrees Fahrenheit. It really held up. It bubbled up there for a second, but then went back down. But everything else came out beautifully. Talk about an extreme test. What's the back of it look like? The back look... Hey, there's a resistor. Check that out. It even picks up errant resistors. No, it doesn't look bad at all. So, besides the extreme little spot right here, where I started getting a little too hot with the torch, this thing really held up. So yeah, it'll hold up to 1,000 degrees easily. Okay, now that we got that fire and everything else taken care of and the mat's all cleaned up again, here's the second product. This is a 7-decade programmable resistor board that I needed. If you remember from my last video, we were playing with the AA LED boost, and the resistor values were wrong from the resistor calculator I used online. So this will help me find the exact resistor value I need. So inside, yes, electronic salon, bought from Amazon. You have extra jumpers, and you have the board itself. And you have your 2 connections, and they also have 1 ohm resistor, 10 ohm resistors, hundreds, 1,000s, 10,000s, 100,000s, and 1 megs. And if we flip it on over, we can see the exact same again. All SMD resistors, version 1.0. But even with version 1.0, I am not seeing any problems with the soldering on here. That all looks good. And these are all half-watt rated, if I remember correctly. Yeah, half-watt, 1% rated. So, let's see how good this unit actually is before we connect it up. So now this is a direct short right now, since everything's set to 0. So it's a direct short through. And granted, this thing is not exactly precision, but you can see it's 0.0002 tenths of an ohm, 3/10 of an ohm, depending upon which way I touch it. So let's go for 1 ohm. Okay, so we still have that 0.2 sitting there. Do we still have that at 9 ohms? $9.2, yeah, we still have that 0.2 still sitting there. Let's try 60 kilo ohms. Definitely 1%. 400 kilo ohms. Yep, definitely 1%. Mega ohms now. About 8. Still not bad. I mean, it's close enough for a board that's as cheap as this. That's not bad at all. So let's go ahead and connect it up to this unit and see if we can find the correct resistor values we actually want. Okay, so I got the meter set up on milliamps right now, and we have the output of the boost converter through the center of my solder jumper running into the unit, then back out, positive into the positive of the meter, negative is going to come on over and connect. I soldered a wire to the output side of one of the resistors, so this way it basically takes it out of the loop. It's direct through. So we can actually find the correct resistance that we want. And since if I leave it right here, this is 0 ohm, actually 0.2 as you saw. We will blow that LED in a couple seconds. So just to start with, let's start with about 50 ohms, because that's definitely a lot more than I was originally using, my 7.5 and my 22 grip. There we go. And we can see even on 50 ohms, we're pulling 11 milliamps still. Now honestly, I have 2 of them sitting upstairs for the last few days, and I have them set right now at 4 milliamps output. I've already tried this before, the video. So I believe I was using like 265 ohms resistance, and they're still bright, believe it or not. Here, let me shut this light off. Using it as a night light. So let's put in 500 ohms resistance. See, now we're down to 1.39 milliamps. I think I want to have a low setting around 2 milliamps. So, see, now it's an open circuit. Let's go down to 400. Oh, not enough. Okay, too high. So we want to get down to 2 milliamps. So now let's move over to our 10 ohm range. Let's do, what's that be? 340? Oh, jeez, I got lucky there. 330, yeah, just a little overshot. 350, a little under. So for 2 milliamps, that'll be 340 ohms for the 2 milliamp settings. I think I'm going to have a high setting as 10 milliamps. So now let's find out what 10 milliamps will be. So let's set this back down to 0. And what's 100? Okay, so 100 is not enough. Don't move that jumper back over. You'll short it out first. Let's put it back to 50. Okay, so we're still a little high. What does 60 ohms give us? Okay, we went too far, so go back to 50. And let's go 55. A little bit more. 56. 57. I think I'm going to stick with 56 ohms, unless I can't find exactly a 56 ohm surface mount resistor on Mouser. But we're going to leave it at 56 for the time being, because that's close enough, and that's definitely brighter. So that's 56 ohms. So this way, now when I go to redesign this, and I believe I am going to put 2 switches on this box. Someone in my comments for that video asked if I can put a switch in here, and I wasn't quite sure if I wanted to or not. So what I'm going to do is actually put 2 switches. I'm going to put an on and off switch, which will actually control the enable on the boost circuit and turn that on and off. And then I'll put a switch for low power or high power. In this case, it'll be right around 2 milliamps and 10 milliamps output. The other thing we're going to switch is we're going to switch this from a cool white 5700 Kelvin light down to probably a warm white 2700 Kelvin, because it'll be easier on your eyes at night. So these are the 2 units I bought off of Amazon. I'll have the links for them down in the description of the video. Thumbs up, and I'll see you next video.